Let's look at how Preddle can be used for machine learning or data mining. Click Data Mine and then Settings to set up some machine learning runs. There's some reference information down the bottom here that will come in handy in a minute, so let's quickly just have a look at it. First of all, here we've got a summary of the workspaces that are available in this data set. We select our data set from this drop-down menu here. Each workspace has different response and offset variables. Recall that for each one we are basically modeling a ratio. Frequency, we're modeling claim divided by, well, the denominator is 1 for each record because we've selected none for the offset, and so on for the other workspaces. In setting up the workspaces, the response variable that we selected was the numerator in the ratio of interest, and the offset variable is the denominator. In the claim frequency workspace, we are modeling the ratio of claim count to exposure, and as I said earlier, each particular record in the data set we treated as being 1 unit of exposure, so we selected no offset variable, which automatically makes each record contribute 1 to the denominator. In the data set, the claim variable, which is a claim count, sums to 1,380, while the number of records sums to 5,800. For the claim size workspace, we are modeling the ratio of claim cost to claim count. The claim cost variable sums to about $8.77 million, or pounds, if we think about it as that number not being dollars but being pounds or some other currency, while claim count sums to 1,380. For the loss ratio workspace, we are modeling the ratio of claim cost to own premium, and similarly the claim cost variable sums to 8.77 million, while own premium sums to 9.6 million. Below that is a description of the algorithm working. To use the frequency workspace as an example, the overall ratio is 1,380 divided by 5,800, which is about 23.8%. So we can think of the claim frequency for the whole portfolio as being 23.8%. Now, there will be some segments of the data set that have a ratio much greater than this, or a claim frequency much greater than this average, and other segments that have a ratio much smaller. We've already explored what some of those segments might be in the GLM modeling, but this algorithm can automate a lot of that. This algorithm splits the data into smaller and smaller segments based on the predictors that you specify. For example, it might look at the whole data set and then decide to split on younger than 40 years old versus older than 40 years old, and then within the younger than 40 years it splits into male versus female, and then within males that are less than 40 it splits into garage versus other, and so on. Each split is chosen by the model automatically, such that the difference in ratio between the two groups is as big as possible. And it will keep splitting in this manner until it can't split anymore, while each segment meets minimum size conditions that we specify. There's also a penalty term in the algorithm to ensure that at each split, two subsegments are as equal in size as possible. Now, we want the subsegments to be fairly equal in size, with the ratios of each subsegment as different to each other as possible. Now, importantly, this splitting algorithm can not only be used to segment the ratio of interest in each workspace, but having fit a GLM, we can use this algorithm to segment the residuals from the GLM model. Now, residuals are the actual value minus the modeled value for each observation. So, for example, if there was a claim on a particular record, the actual value would be 1 and the modeled value might be 0.8. So the residual is 0.2 because the actual is 0.2 higher than the modeled. If the model is systematically mispredicting particular segments, then this process should find it. Taking the earlier modelling example, if we hadn't fit the interaction between driver age and sex, the model would have fit the average rates for young drivers to both young males and young females. Therefore, the model would have underpredicted claim frequency for young males and overpredicted the claim frequency for young females. Now you can find this by taking that interaction out and then segmenting the GLM residuals that we can select here from the frequency workspace rather than segmenting the frequency ratio itself. So if you want to segment on the response, you pick this from the drop down. If you want to segment on the residuals, you pick the type of residuals that you want to segment on. So let's let the algorithm use all the predictors, and we'll run it over the response. We can create many different runs, each one with slightly different settings. Because of that, we need to name each run. So let's call this one datamine1 run to be creative. Now, as with the GLM modeling, we need to choose which workspace we're interested in. So select claim frequency. We want to model or mine the response for now rather than the residuals. If we did want to mine the residuals, you would just build the GLM over this workspace first and then come to this screen and just pick whichever type of residual you're interested in mining. Then we choose the minimum observations per node. A node is effectively a segment. The obs is the minimum sum in the denominator in the ratio in that segment. So in the case of frequency, this is referring to the minimum number of records in each segment. There are 5,800 records in total. So with a 1,000 minimum, we would expect around 3 segments in total, since each segment will end up having between 1,000 and 2,000 records. This is because any segment that happened to have more than 2,000 records after some split, that segment could further be split into 2, such that each subsequent subsegment would have at least 1,000 records in it. Now we do want more than just 3 or so segments. So let's reduce this minimum obs to 500. Let's leave the penalty factor at 0.2. Now in the data mine process, we don't have the benefit of standard errors, confidence intervals, and significance tests to validate the model. In order to validate it, we need to split the data into a training set to actually fit the model, and a validation set to test the model against. Preddle randomly splits the data for us in the proportions that we specify. We recommend splitting 70% of the data into the training set and 30% into the validation set. But you can change that here if you prefer. We won't. Let's just fit the data mine. And almost done.